All right, we are going to finally talk today about the vertical shift within the sine and cosine function. So I want you to think real quick about our original function, this x cubed, back from our transformations unit, and what would adding 2 on the outside do to that function? Well, it would move it up 2 units. So similarly, we're going to be shifting our sine and cosine graphs up and down along the y-axis. A vertical shift will officially move the midline. You've heard me say that word a lot in these graphing problems. And today we're going to start doing stuff with the midline to move our graph up or down. So, graph 2 periods of this y equals 3 sine of x minus pi plus 2. We're going to go through, we're going to identify all of our information just like we have been before we start creating the picture. So our amplitude comes from our vertical stretch, which is the absolute value of 3, so in our case just 3. The period comes from, if I write this, again I'm going to factor out my greatest common factor, which in this case is just 1. That's not very exciting, but I'll write it anyway just for consistency's sake. And then we have this plus 2 going on, which I'm going to write in red. So our period's going to be 2 pi over 1, which is really just 2 pi. We've seen that before. The horizontal shift is going to be to the right pi units. And now we have our vertical shift. This is going to be up 2 because of this plus 2 on the outside of the function. And then our intervals are still just like we always have had them. It's the period divided by 4, which in this case is pi over 2. All right, so every time I've started graphing, I've started by graphing the midline right at 0. This time, my midline is supposed to be moved up 2. So I'm going to start at 2. And there is my midline. Okay, I'm just labeling it just so we can make reference to it. From there, then, I'm going to count the amplitude of 3. Well, if I already was at 2, now this would be 3, 4, 5. And my lower value, my stretch going the other direction, would be down 1, 2, 3. So this is really at -1. Okay, so you see how we've shifted our whole graph up 2 units. The next thing then that I usually mark off is my horizontal shift, because I'm going to get the x-axis set up now. So my horizontal shift is to the right pi. I'm going to arbitrarily choose that this is a distance of pi units. Then I'm going to count my intervals just like I normally would. So I need to do pi, and I need to add to that pi over 2. So this really was 2 pi over 2 plus pi over 2. So my next interval counting is going to be 3 pi over 2. Okay, which again, just spacing wise, taking pi over 2. Okay, 3 pi over 2, then this would be 4 pi over 2, and then 5 pi over 2, and then 6 pi over 2. 3 pi minus pi got me my period of 2 pi. This is all working out so well. This was 6 pi over 2. This would be 7 pi over 2. This would be 8 pi over 2, 9 pi over 2, and finally 10 pi over 2, which is really 5 pi. And again, 5 pi minus 3 pi gets me that magic period of 2 pi. All right, so I've done everything that I'm used to doing. Got my vertical shift with my y-axis all set up. Then I did my horizontal shift with my intervals all set up. Now, could I have gone backwards and made this pi over 2 and then backwards? Sure. Okay, but remember we only have to graph 2 periods. So now I got to start thinking about the shape of this sine graph. The sine goes like this. And every time that I've plotted that first point, I don't ever say anything about 0. I talk about being on the midline. Well, now my horizontal shift is here, and I'm supposed to be on the midline, so that's going to be right there. So I've got this point on the midline. My next point is supposed to be at the high amplitude, which in this case is 5. Then I'm supposed to be back on that midline. Then I'm supposed to be at my minimum or my low amplitude, which was -1. Then I'm supposed to be back crossing that midline. Okay, well now if I continue this, on the midline, high amplitude, on the midline, low amplitude, back on the midline. Now this graph looks a little funny because my distance here is not quite equal to my distance there, and I apologize for that. But what I want you to notice is that we've taken our entire sine wave and we have just shifted it up 2 units. So my amplitude, this distance from the midline to the high point, is still 3. Midline to the low point is still 3. It's just that that 3 is looking a little bit different on our graph because of where we started. So we're really going from -1 until 5 for the range. All right, let's try it again. So we've got a amplitude of 2 that comes from our vertical stretch. If I rewrite this, I can factor out a 1, because that's my only greatest common factor, x plus pi over 2, and then I have this minus 1. So the period's still going to be 2 pi over 1, which is just 2 pi. My horizontal shift is going to be to the left, pi over 2. My vertical shift is going to be down 1. And my interval, we're going to count by 2 pi over 4, which is really just pi over 2 like we've seen before. All right, so I always start by drawing my midline. My midline this time is at -1. Then from there I count my amplitude. Well, my amplitude here was 2. So I was at -1, I need to go up 2, which lands me at 1. I need to go down 2, which lands me at -3. So again, 2 away from the midline in either direction. I've got my vertical axis set up. Next thing then I got to get my horizontal axis set up. So I'm going to start by going left pi over 2. I can pick where that is as long as I'm somewhat consistent with my spacing. Here's -pi over 2. Then I'm supposed to count by pi over 2's. Well, that's kind of nice because -pi over 2, if I add pi over 2 to it, I don't even need a common denominator. That takes me straight to 0. That's nice. Add another pi over 2, and another pi over 2, and one more pi over 2 to get my 5 important points for that cosine wave. So -pi over 2 to get to 3 pi over 2 is a total distance of 4 pi over 2, which is really 2 pi. It's all coming together so nicely. So I'm going to count another period. So 3 pi over 2, this would be 4 pi over 2. This would be 5 pi over 2, 6 pi over 2, and 7 pi over 2 is where I'm going to stop because 7 pi over 2 minus 3 pi over 2 is really 4 pi over 2, which again is that 2 pi. So now I'm ready to graph. So I want to go to my starting point, and because this is a cosine graph, I'm going to start at my high value. So my horizontal shift was at -pi over 2, and I want to start with my high amplitude. Next tick mark, I cross the midline. Low amplitude. Next tick mark, I cross the midline. Back up to the high amplitude. So you'll notice we're kind of ignoring the x-axis as a line here, right? We're just worried about the midline. That's where we're crossing for our cosine graph. So again, cross the midline, low value, cross the midline, high value. There's our 2 rotations of cosine. I, of course, could keep going in either direction because of its periodic nature. All right, it is your turn to try this one completely on your own. I'm not even going to give you the helpful writing of factoring out the 2, even though I just gave you the hint that you should maybe factor out the 2. So go ahead and try it. I'm going to put up all of my work, and then when you unpause, I will go through and I will explain all of it, but I really, 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 really want you to try this one on your own to see if you can do it without my guidance. I believe in you. Good luck. So here's your final graph. Mine came out a little bit tiny because that amplitude of 1/2, but we started with identifying all of the information. I then drew my vertical shift, right? We always start by drawing the midline. Then I counted the amplitude up and the amplitude down. Then I drew in my horizontal shift of pi over 2. Remember, I picked how big this distance was. Then I had to count by pi over 4s, which is a little bit smaller. That's why those spaces are smaller. Sorry, I just dropped my microphone. From there, I then started on my midline. high point on my midline, low point on my midline because of the sine wave. Now, something we've kind of been steering away from is just remembering this idea that this was an input of theta, and this is an output of whatever this y value is, which in this case is all of this. So if I pick any angle, let's say I picked 3 pi over 4. If I take 3 pi over 4 and I plug it into this equation, okay, so 2 times 3 pi over 4, the 2 and the 4 can cancel, so I really get 3 pi over 2. Well, 3 pi over 2 minus pi is just 1 pi over 2. The sine of pi over 2, we know from our unit circle, is equal to 1 times 1/2 plus 3. Well, 1/2 times 1 is a half plus 3 is equal to 3.5. So my input was 3 pi over 4, and my output was 3.5. Well, look up here. In went 3.4, out came 3.5. Don't lose sight of what you're doing when we think about these graphs. You're just working with transformations, taking a parent function and moving it up, down, left, right, stretch, shrink, reflect, whenever that negative sign comes in, which we haven't seen in a while, but it will be back at some point, and just putting it all together into the eyes of transformations. Good work!